There we go. So welcome everyone. I'm Eline Krijkamp and I have, I think, to speak in this microphone, right? I hear myself. And I have the honor to kick off this presentation with my, this session with my presentation entitled From Spreadsheet to Script, Streamlining Data Collection and Probabilistic Sensitivity Analysis with Excel and R. And in the next few minutes, I will walk you through how we kind of created this workflow to kind of reduce the friction in the process of getting model input and preparing this model input for your probabilistic sensitivity analysis, kind of in short PSA. And I believe that this is improving our collaboration between the modelers building it in R and the domain experts for the literature search in that particular reason. But I don't know about you, but as the first speaker of the day, I always have kind of this idea of like setting the tone of today. And maybe some of you that follow after me might think like, I don't hope she set the bar too high before it's my turn to present. But there's no need to worry because it has been proven scientifically that what you remember from an experience, like the memories you keep, are kind of the peak and the end. So I think the end is Jack Entinger, if I remember your name correctly, and Rob, so it's not me. And I can also tell you, this is definitely not rocket science. I think many of you here in the audience have done what I've done here, and you have a version of this on your computer. However, I think what it is that none of us actually took the effort to really formalize it or to have it like in a ready-to-use template, tested it, or made sure that we took the effort to communicate it to a larger audience of using it. So therefore, my presentation is definitely a little bit of a warm-up exercise to get you guys started and to have this discussion together on how we can join all of our forces into what we are actually so enthusiastic about, getting R to the larger audience of really practical implementations. So this work or this idea actually started back in the COVID pandemic, where we were in need of decision models quite fast, but also the evidence was changing on a really rapid basis. Back then I worked closely with clinicians because they were there treating their COVID patients on a daily basis, being up to date with the current clinical trials and what they were seeing actually happening. Well, we were building the model, so we were in this really constantly change of available evidence. And while a probabilistic sensitivity analysis is always needed to do, it became extra important given this large uncertainty that we have in our inputs. What I would like to stress here is that, of course, we all know that we can do R and model building so great that we can do the statistical analysis and use this input in our model. But I'm here talking mainly if you have data that comes from literature of external resources that you would like to combine with the data that you already have. We actually noticed then that it was quite challenging to collaborate with our framework and those that have in the literature to put it in the right format. In the end, we were doing that, so to say. But we thought, can we actually make that process easier or better, something smoother, to make sure that the input goes in maybe something in Excel frontend, and then R will take care of the rest. However, like I said, I think many of you have done things similar. So therefore, I would like to ask you, how do you bring in external input parameters into your R workflow? And what are your biggest challenges when you collaborate with kind of non-technical stakeholders? And would like to invite you to turn to your neighbor and discuss this in the coming 2 minutes. Okay, guys, the time was up. I heard you guys chatting a lot. So thank you for this conversation. You can continue though with something. I would like you to not do this again. There we go. So you talked about like how you're doing it and the struggles, and I would like to turn you to your other neighbor, so the person you haven't spoken with yet, and now discuss your dream scenario. So what would it make it perfect for you? Let's take 1.5 minutes. Yeah.
Is your headphone set, for the audio?
I think so, but otherwise I manage.
No, because the thing was open. There's nothing actually.
Oh, I don't know.
It's actually sitting here on the finger on the button.
Yeah.
There's nothing actually coming.
Okay, it's fine. Don't worry. Okay, guys, thanks. Time is up. So I would like you to keep this dream in mind. So keep it there, and let's wait for the discussion because I would like to hear what your thoughts are. I would like to go to our solution, like what have we done so far. So what we tried is to create an Excel template, kind of an intuitive way to define input parameters, their distribution and their uncertainty, and combine that directly with an R script that will read that data and transform that into a PSA data set that you can use for each of your iterations. So that comes from this kind of process. We have the Excel and this R. The data will be generated for each kind of your sampled input parameters, and then it comes with a list. And this is kind of an essential part because we're talking here about kind of a function-based model that is depending on one list. So you can see that as kind of everything that the model needs in order to run it. But then what I need to do in my PSA is that I need to, every iteration, I need to replace the parameter values by their sampled values. And then at the end, if I run my model for, 10,000 times, I get the outputs of my effects cluster list. This is the part where we will be focusing on. And for demonstration purposes, I only go for a beta distribution, something that we all use frequently, and it will apply to many others, of course, but this is for demonstration. So in this Excel sheet, we have kind of like a clear instruction of like how do you use it, how can you, which columns to modify and what not, and how do you put it into a format with some drop-down menus about the type of distributions, and then also for these distributions, their parameters. And that would look like something like this. So you have kind of a column, you give it a particular name, and we recommend you to do that something consistently. The type indicating is this a probability, is this a cost or a utility, and then the distribution, which comes from a drop-down menu. And then you can, for example, for this beta distribution, have like your alpha and your beta, meaning the parameter values and their types, or you can do that in the form of a mean and a standard error. And then it calculates the mean. So that's kind of an essential thing. This mean that we have is kind of like a format that we will show later on. As I said, it's conditional drop-down, so in case you already said that your probability of dying on an annual time is a probability, you can only from your distribution choose a beta. It now has also a uniform of a fixed in case you really want to. But if there's nothing specified, if you see here, so there's nothing in the cost, you have like many other options that you would like to pick from. And then the column of the mean comes with this kind of conditional equation in Excel, no rocket science, but it checks like, okay, what type of distribution do I have? So in case of this beta distribution, and you provided me with something being the alpha and the beta, I would calculate the mean. Otherwise, if you just provided me the mean already, I use it. So that's kind of the part where we this is what we give to the users. They will use it, they will put everything in. And then the parts come for the data loading. What we do, we clean all of this information. We do some checks for missing information or even maybe duplicate information. If someone thought, oh, maybe this is not the right parameter, let's put something new in, and then we're not sure which one to use. So we have this function which is called remove parameters without the unit. So what it does, it will read your parameters. And that what it does, it has a column that's checking which parameters are really essential. The references are essential, but not for making the model run. And then it checks like, do I actually have all of these parameters? What it does next is kind of like check if there's anything that's missing. So if there are like empty rows, it will kind of remove those needs to be removed, and it will inform you which one it's removed. So you can kind of check, okay, in my sheet, does that make sense? And it checks for duplicate parameters, as I said before, and it also prints, okay, if you have those. And it could even happen that after we clean the data, there's nothing in there anymore, because for whatever reason you messed up so badly that you need to revisit. And then it returns to you a kind of like a clean parameter set. Then what we kind of do is we validate, like, okay, we have it now clean, so we can work with it, but does it make sense? So in case of this beta distribution, what it will do, it will check, do I actually have my options? So it will check it for you, and if there's nothing for an parameter 1 and a parameter 2, it will tell you, okay, you have to do this. For many of you that might sound quite obvious, but tell me, there are like people that really appreciate this. And otherwise it can also check, like, do you have like valid numbers for making sure that are at least positive numbers. And then it checks if the input parameters are valid. So right now what it does, it kind of like stops at every warning, and ideally we would like to make sure that it reads everything and kind of like put like a kind of a document in the sense like, this is actually the things that you need to check and revisit. So it's kind of like now you need to, it's still this workflow going back and forth. We have kind of this idea to check for consistency and kind of naming. So in case we have this demonstration that you say, okay, probability, we start with a p underscore. For readability of your R code, it could be useful if you be consistent for kind of clusters of data on how you name it. So we're kind of like working on making either a same prefix or suggest users on how can you make your naming conventions better, and it kind of checks the distributions. Although it came with a drop-down menu, you think, okay, that will be fine, but there's still the option to overrule kind of those things. So we still have like this check, like, are you sure if you have like this beta distribution or a probability, is that matched? Kind of a check to make sure you did it intentionally. So now that we have kind of this proper data set, we have this function that says make your data set, and what we will do, we'll loop over all of this parameters. The looping part can be discussed. You might want to factorize that component, of course, but it will check the type of distribution, and based on the information that it got, either an alpha and a beta, it will immediately sample your input parameters, or otherwise, if you got the mean and the standard error, it recalculates your alpha and your beta for you, and then does the same thing. So with this function from the Excel sheet, you now have a data structure with the number of rows being your PSA iteration and the columns being your parameters. And you can do some visual inspection. So after you have done that, does it make sense? How does it look like? It will provide you the parameter names, the number of samples that you had, both the theoretical mean, so what did you actually have in your Excel sheet, and what do we have given our sampling. So then what we need to do next is that we have this structure, perfect, with the data set, as I said, number of rows, PSA iteration, number of columns being the parameters, and we had this list that our model depended on in order to run, and we need to kind of like replace that part with the specific iterations. So we have this function update parameter list, and what you give it is like your list of all your parameters that your model needs and your data frame given each iteration, and it will just checks which information does it have and only replace those, and whatever you didn't provide, it will keep it constant, assuming that was fixed and intentionally. So kind of like what this approach will do is kind of that we were able to merge this data, literature data, into a format that we can put into our model. You can also think about, like it's not shown here, of like columns for treatment, country, or even subgroups that you would like to split to make that even in a faster process, and having different lists for different combinations, of course. What's not currently there, but what we would like to have is, of course, kind of like a certain scenario-based script setting, which you can say, okay, if I would like to have several scenarios, this is how it would look like. Because in general, we often still do that manually, or we do extreme value testing, especially with the teaching examples that are using a lot. It could be nice to have them also at separate sections in your Excel. And we're kind of like balancing this part, like how do we make this Excel component really with fixed drop downs? Where do you kind of like make sure it's really even in a shiny situation, or how to fix it, versus how do we keep it as simple as we can, combining it with R. As I said, this is no rocket science and not just done by me. It's done with collaborations of many others or in projects that we worked on. And actually what I would like to invite you as well is that we have kind of like now currently a spreadsheet driven kind of PSA structure, and I would like to discuss with you as well how can we make that into a larger setting, because in the end that's I think what we're here for, to make this R for HTA uptake steeper and kind of flatten the learning curve. I would like to open it for discussion.
Thanks very much, Eline. Are there any questions from the audience? I'll start with, oh, nope.
Hi, thank you very much. I'm Jack. It sounds...
Oh, there's a microphone. Hello. It sounds like, well, no, how often do you get the data that you want in your spreadsheet? How often do you have to go back to the people and ask them to redo it?
Yes. So that's a great question, and it's really a workflow going back and forth. So it's not per se that you can kind of like give it, okay, fill it in and it works, because it depends, of course, like what are the assumptions of the data that you have, in which structure are these conditional probabilities, how are the calculations in between. But I do realize that from a project where I got this invitation, yeah, we do have all the data. It's just, can we invite you to build the model in R? And that sounds really like, okay, I don't need to do anything with this input, but in fact, we all know it's garbage in, garbage out, and it needs to fit this structure. And having this really helped me in the process of, okay, I see all this data, can you make as much as you can this available in this structure? Will definitely not be a plug and play. We're far from that at this stage, but it will help to kind of get it in a way that's easier, yeah, to do it. Does that answer your question? Yeah.
Questions with the microphone so people online can hear.
Yeah, so do we have any other questions in here or online? If not, I'll just ask the obvious question. I can think of some reasons why not, but why not use R-Shiny GUI of some sort to get data inputs that way?
Yeah.
Because at least then you can run the model. Like the user can change the inputs and run the model. In this case, they can't run the model if they're editing the Excel.
No, that's true. So there you're saying kind of like, I think from that part, you have your model already with some either placeholder data or a way to run it, right? So you have the Shiny application in there. I think this is more in the stage that we're really collecting all the information, working closely together to get it to a final situation. That's the way I have worked so far. And that's the reason why I think it's nice to present it in an Excel sheet. Also for a meeting, if we kind of like show, okay, this is what we have, this is the way we continue. I found it more intuitive to have kind of a spreadsheet together and discuss, okay, what are the sources that we had, what are all the alternatives, rather than going into a Shiny application, plugging in what we wanted to have. But there might be a way of like doing it there, which is as intuitive as the workflow as I continued doing it like that.
Okay.
Yeah.
And,
But that's a big thing that I also would like to see the interest here. Like, the Shiny is a great way. Sometimes I feel like if this is as simple and it works, maybe there's no need for that component.
okay. Thank you very much. And let's thank Eline again.